Want to see something funny? You know what they all had in common? Misuse of levers. And that's what we're going to talk about today. Is we're going to talk about levers, and we're going to talk about how we use them and the different classes of levers. All right, yesterday we started talking about, what was it? Tuesday we started talking about simple machines and what machines do. Machines we know are any object that makes work easier. And we talked about an effort force and a resistance force. Let's go back and look at that. The effort would be where we have to actually apply the force, and the resistance is the hard, what we have to lift. So we're going to be looking at how levers help us with overcoming the resistance, okay? It's like really Star Wars-y stuff. So what is a lever? A lever is any bar that turns on a point. And the spot where that bar turns or pivots we call a fulcrum. Some common levers that we see are the seesaw, which we don't really see seesaws anymore because of what you just saw in those videos. Also wheelbarrows and brooms as well are considered levers. So we use levers to lift objects that are otherwise too heavy for us. This handsome fellow right here, his name is Archimedes, and he was a mathematician who lived more than 200 years before Christ was even walking this earth. He was one of the first men to study simple machines. And he once said that if we had a long enough lever and a fixed fulcrum, remember that spot, that the pivot point of a lever, that if we had a long enough lever and a fixed fulcrum, that he could move the earth. Now I know that seems a little outlandish, but his theories are correct. Now Archimedes, he could never prove this statement because he understood that levers make work easier, but having one that's as big enough to stretch under the earth is just absolutely ridiculous. But fun fact about Archimedes, he's the creator of the formula for pi, which you guys all learned, and also that saying, Eureka, when he discovered density. The story behind that is he was sitting in a bathtub after work one day, and he had a bar of soap, and he dropped the soap in the bathtub, and the soap started floating, and he got to thinking in his mind, why is that bar of soap floating? And he came up with the idea of Eureka. Well, the story or the myth goes that he got so excited, he jumped out of that tub, took out the front door, and started running down the road butt naked, yelling, Eureka, because he was so excited about it. Whether that's true or not, I don't know, but I think it's a fun story. All right. So scientists classify levers into 3 categories depending on where the effort and resistance, that's the load, are located in relationship to this pivot point that we call the fulcrum. So we have our first class lever that looks like our seesaw, where the effort and the load are on either side of that pivot point, kind of like a seesaw. We have the second class lever where the pivot point is at the end, the heavy mass or the load is in the middle, and the effort to pull up is on this side. This reminds me of a wheelbarrow. This would be the wheel. Here's where we put all the stuff, and this is the handle that we lift up. Then we have our third class levers. The pivot point again is at the end. The effort is pulled up in the middle, and the load is on the outside, kind of like a fishing pole. So our first class levers. Again, the fulcrum is located between the effort and the resistance. Seesaws, crowbars, these are both first class levers. Now, it makes a difference how long that lever is to make work easier. If I have something like a pencil to lift a big rock, I'm not going to get any leverage under that. But if I have like a really long crowbar that's 10 times as long as this pencil, then it would be no problem lifting up that rock. So There are different size crowbars that you can get, and they all have a different mechanical resistance to them. All right. If you use a can opener, you're using a first class lever. So let's think about this. So a paint can opener. If you ever try to open up a paint can, there's these divots in here that you have to put something in, like a screwdriver, or they have like a paint can key that you can open. The fulcrum is actually the rim right here. This is the pivot point that I could put the lever on. The lid itself is going to be my resistance. This is the hard part to lift or to get open. Remember, if you think of resistance or load, that's the heavy part that you have to overcome or lift or pick up. The fact that I'm pushing down on the other end produces the effort. This is me putting in the effort to open this up. A pair of scissors would be another example of two first-class levers that are working together. So if you look, this would be a lever and this side would be a lever. The load is in the middle. Here's my pivot point right here, and the applied force are those two ends coming together. Second class levers have the resistance or that load in the middle between the effort and that fulcrum, that pivot point. You can see that the effort is being pulled up. Some examples of this are a door or a wheelbarrow. So think about this. Almost anything that has a hinge is considered a second class lever. The effort is I'm at the outside of the door opening it up. The load is this heavy door, but the fulcrum is this pivot point right here. The same thing with the door. If I was going to push a door open, I'm usually pushing on the side that opens, not near where the hinges are. And again, here's our effort pulling up on the wheelbarrow. The effort or the load is in the middle, and then I have my pivot point, which is the wheel. Another example of two second-class levers working together, kind of like the two first-class levers made scissors. Two second-class levers working together would be a nutcracker. I have the fulcrum here, my load is in the middle, and I have to squeeze these together in order to crack this open. No funny jokes, boys. In the third class lever, the effort is between the resistance and the fulcrum. So in these levers, a little movement by the effort gives greater movement at the resistance. Let's look at some examples. A broom and a fishing pole. I can move the end of the broom a little, but at the floor the broom moves much more than the little that you moved it. So if I'm holding it right here and I'm pushing, my pivot point is up here by my hand. I'm not moving both hands at the same time. I'm not sweeping like this. Okay, if you are, you've learned wrong. My pivot point here, and I'm using this bottom hand in the middle to push the broom. The same thing with fishing poles. I know there's a lot of you that are fishers. My pivot point is the bottom hand. My middle hand is what is actually pushing the pole forward. These are considered third-class levers. An example of two third-class levers put together would be a pair of tweezers. I have my fulcrum in the middle, the load on the outside, and the effort is being squeezed in the middle. Your assignment for today is you're going to look underneath this video, and I'm going to have a bunch of different items listed there. You need to send me something that has each of those items listed as either a first class lever, a second class lever, or a third class lever. I will have pictures there of where the load, the fulcrum, and the effort is for first class, second class, and a third class lever. You need to organize those items based on what type of lever they are and send that to me.